Hello. So let us do a question from chapter 7, exercise question number 7.8. Exercise question number 7.8 it is. So I'll just read the question once. A non-uniform bar of weight W. So the bar is non-uniform. Here in this question, the diagram is given. So if the bar is uniform, then the weight will be from exactly the center. The center of mass will be at exactly center if that road is a uniform road. Here it is given the road is non-uniform, so the weight will not be from the exact center. So as shown in the diagram, you can see the weight is towards the left side. Okay, a non-uniform bar of weight W is suspended at rest by two strings of negligible weight. So two strings, when two strings is supporting the bar, whenever there is a string supporting the bar, the force on the string we call it as tension. So the two strings are holding the bar like this, so the tension will be in upward direction. So I can mark the tensions. This exact diagram is given. I'm going to make the assumptions which we are making. So here the tension is actually in the upward direction. So this tension I will mark it as T1, and this tension I will mark it as T2. Now I can resolve these tensions into two because this angle is given. So I can resolve this tension into two components, that is vertical and horizontal component, T cos theta and T sin theta. So here if I draw a horizontal like this and a vertical like this is 53.1, so this will be also 53.1, and here also I will draw a vertical and a horizontal, and this will be 36.9. Okay, now coming to the resolution part, if I resolve, listen, coming to the resolution part, if I resolve, I can resolve this T2 into two components. Near to theta is always cos theta. So here near to theta is this. So this will be T2 cos 53.1, and this will be T2 sin 53.1. Now here near to theta is T1 cos 36.9, and this will be T1 sin 36.9. So that much is the drawings which we are making in the given diagram. Okay, now the bar is 2 meter long. So the length of the bar is given as 2 meter. Calculate the distance D of the center of gravity of the bar from the left end. So from left end, the center of gravity is the point at which the entire weight of the body is concentrated. So here it is W, so that distance is what we need to find. For doing this problem, we have to apply the condition of equilibrium of a rigid body. Okay, so equilibrium of a rigid body concept, that is translational equilibrium and rotational equilibrium conditions we will apply, and finally we will reach at the answer. Okay, now let me explain the diagram once again. You have a 2 meter long rod. The weight is acting at a point which is at a distance of D from the left hand corner. Now two tensions T1 and T2, I will resolve it into two components. Okay, now the first we will apply the condition for translational equilibrium. Condition for translational equilibrium means sum of all forces is 0. Translational equilibrium means sum of all forces equal to 0. Here when you check, the forces are T1 and T2 which are resolved. So those forces will come. So T1 sin 39 and T2 sin 59. T1 sin 36.9 and T2 sin 53.1. So these are the only two forces acting in the horizontal direction. So sum of all forces in the horizontal direction to be 0, that is the first condition I am taking. So here that is what I have taken. Sum of all forces in the horizontal direction is equal to 0. all forces in the horizontal direction is equal to 0. Okay, so sum of all forces in the horizontal direction, that is all the forces on the left side will be equal to all forces on the right side. So I just equated T1 sine 36 is equal to T2 sine 53. T1 sine 36.9 is equal to T2 sine 53.1. Now T1 into sine 36.9, that will be given for you. Sine 36.9, you can take it as 3 by 5. That is 3 by 5. Then cosine 53.1, you will take it as 4 by 5. And cos 36.9 is 4 by 5. And cos 53.1 is 3 by 5. These are the values which you will be substituting while doing the problem. Okay, these are the values of sine and cos which you will be substituting in the problem. Okay. So what we are doing is equating the forces on the horizontal direction. So T1 3 by 5 is equal to T2 4 by 5. Okay, now from here 5 will get cancelled. Here you can see this 5 and this 5 will get cancelled. So 3 T1 will be equal to 4 T2. From here you will get T1 is equal to this 3 will go to the denominator. So T1 is equal to 4 by 3 T2. Put that is equation A. Okay. Now next we will consider all the vertical forces to be 0. Looking at the diagram, see sum of all vertical forces. Here the vertical forces is up to forces. T1 cos 36.9, T2 cos 53.1, and down you have W. So these are the 3 vertical forces. So 3 vertical forces to be 0 means you will take upward positive and downward negative. So sum of all vertical forces to be 0. T1 cos 36.9 plus T2 cos 53.1 minus W. Why it is minus W? Because W is acting in the downward direction. Now we will substitute the values. Cos 36.9 is 4. Cos 53.1 is 3 by 5, which is equal to W. Now you will take the LCM. So you will get 4T1 plus 3T2 is equal to 5W. Okay. So 4T1 plus 3T2 is equal to 5W you will get. Now what you will do is here for T1 you will make the substitution. So T1 is equal to 4 by 3 T2. So that you will substitute. Substituting this equation A in equation 2, you will get 4 into 4 by 3 T2 plus 3 2 is equal to 5W. Now 16 by 3 T2 plus 3 T2 is equal to 5W. You will take LCM. So you will get, if I take LCM this step, I'll just explain. So 16 by 3 plus 3 T2, right? So 3 I will take common. So 16 T2 plus 9 T2 is equal to 5W. Now this 3 I will take to the other side. So 16 T2 plus 9 T2 is equal to 15W. So 16 plus 9 is 25. T2 is equal to 15W. So that is how you will get this step. From here you will get T2 is equal to 15 by 25 into W. So 15 by 25 is 3 by 5W. So that is how you are getting the value of T2 here. Okay. Now so what we did, we applied the condition of translational equilibrium. That is, all horizontal forces equal to 0 you equated, all vertical forces equal to 0 you equated. So you got up to this. Now the condition for rotational equilibrium is sum of all torque is equal to 0. So torque is force into perpendicular distance. So for measuring that perpendicular distance, there should be an origin which you should consider. Here I am considering the origin as this point. I will mark this point as A and the other end of the rod as B. So AB is that rod of length 2 meter. So I am taking origin as A, sum of all torque with respect to point A. So I will just draw. This is your A, this is your B. So with respect to this point I will take. So W is at a distance of D. So the torque at point W will be force into perpendicular distance. Force is W. So into perpendicular distance is WD. So then another force passing through A is what? T1 cos 36.9, then T1 sine 36.9, both passing through A. So the distance will be 0. So the torque associated with those two forces will be 0. So no need to consider these two forces. Now the other force over here is T2 cos 53.1 and T2 sine 53.1. So when you consider T2 sine 53.1, that is also passing through A. The line of action is through A. So that also distance will be 0. So you need not consider that. So the next is T2 cos 53.1, which is at a distance of, this is the line of action. So from A, the distance of T2 cos 53 is 2 meter. That is the length of the road. So here the torque will be T2 cos 53.1 into 2. Okay, so sum of all torque is equal to 0 means I can write this is equal to this. Okay, so T2 cos 53.1 into 2 minus WD is equal to 0, or I can just equate because sum is 0, so both should be equal. So T2 value is, here we got it as 3 by 5 W. So 3 by 5 W into cos 53.1 is 3 by 5 into 2 is equal to W into D. Now here W cancels. Okay, so when you take D, you will get it as 9 into 2, 18 by 5 into 5, 25. So 18 by 25 meter you will get as distance D, which is equal to 0.72 meter. That will be your final answer. This problem is very important. This is actually your textbook exercise question number 7.8. Okay, this question is very important. The exact same question teachers used to ask for exam. And this conditions, all what we are applying is important. Translational equilibrium, sum of all forces is 0. Rotational equilibrium, sum of all torque is equal to 0. Okay, hope this problem is clear for you. If it is not clear, message me. I'll explain it bit more detail. Okay, or ask your doubts, so I'll clarify that. Okay, thank you all of you. Bye. Take care.